Hi everybody! Today we are going to be taking a look at area model. Now I know that you've seen this before with multiplication, but today we're going to review how to do it with multiplication and then look and see if we can use this area model for our division, provide a visual model of what we're seeing as we solve a problem. So we're going to start with the multiplication problem. I need you to have your math notebook. You're going to be following along with me, solving with me, okay? And your colored pens. Colored pens are very important, especially when we organize our notebook. So I hope you have those things with you, and we're going to go ahead and get started with the word multiplication problem. So our problem is a grocery store owner ordered 43 boxes of donuts to sell in her bakery section. There are 24 donuts in each box. How many donuts will she receive in total? So as I look at this, I need to pull out what are my two numbers. Okay? I see they ordered 43 boxes of donuts. Oh, pen. They ordered 43 boxes of donuts. And there are 24 donuts in each box. So if I look, we have 43 boxes of donuts and 24 donuts per box. And the question it's asking us to solve is how many donuts will she receive in total? How many donuts will she receive in total? So this tells me that we need to solve with multiplication. We are going to have to do our 43 boxes times the 24 donuts per box to find out how many total donuts there are. So to find out the total, which is unknown. So we are going to use an area model to help us do this. So let's go to our next page. I want you to have a rectangle in your math notebook. Everything I'm doing on this page, I want in your math notebook, okay? So with our area model, we know that we have a rectangle and that we have to take a look at our numbers. So our numbers are 43 times 24, okay? That is what we're looking at. But I don't know about you, but that seems complicated. Those don't seem like friendly numbers, and I can't do that on my own. So I am going to create an area model. So I am going to divide my rectangle into 4 sections. So I have places to divide up my numbers. Now, if I look at 43, okay, I'm going to start and look at 43. I know I can break 43 up into tens and ones. So 43 has 4 tens, which is 40, and 3 ones, which is 3. I'll put my multiplication sign here so I remember what I'm doing. And now I need to break up my 24. So if I look at 24, I see 24 has 2 tens, so that's 20, and 4 ones, which is 4. So you should have your area model set up like mine. Now we just look at each individual problem in those boxes and see what we can solve. So we're going to start with this first one. We look at the number here. We're doing 40 times 20. So 40 times 20. I know 4 times 2 is 8. And then I have to annex these 2 extra zeros. This one and this one. So that tells me that 40 times 20 equals 800. So I'm going to put 800 in this first box. Now I'm going to go and do my 40 times 4. So if I look 40 times 4, let's see, I know 4 times 4. 4 times 4 is one of my doubles facts. 4 times 4, 4, 8, 12, 16. 4 times 4 is 16. And then notice how I'm not doing 4 times 4, I'm doing 40 times 4. So 40 times 4 equals the 16 plus, and x is 0, so it is 160. Now I need to move on. I am doing the 3 times the 20. So 3 times 20. I know 3 times 2 equals 6. So for 3 times 20, I just need to annex that extra 0, and it is 60. And lastly, I have my 3 times 4 for this last box. So 3 times 4 equals 12. All right, now to find our total answer, it's not 800, it's not 60, it's not 160, it's not 12. We need to add all of these together. So take the time, pause the video right now, add them together, and I want us to review our answer once you have one. So now that you've added up, we're going to look and see what we did. So we have 800 plus 160 plus 60 plus 12. So I'm going to start with my ones. 0 plus 0 plus 0 plus 2 is 2. 0 plus 6 plus 6 plus 1. 6 plus 6 is 12, plus 1 more is 13. So I'm going to write down my 3, carry my 1, and then 1 plus 8 is 9, plus 1 more is 10. So I get a total of 1,032. So I know 43 times 24 equals 1,032. Now that we know how to do it with a multiplication, we're going to switch gears. So go to a new page because we're going to do this all over again, but with division. So now that we did area model for multiplication, we're going to switch gears and see how we can use it for division. We're going to do that by watching our visual learning video and following along. Whatever I solve on this side, I want you to solve in your math notebook.
How can you use area models to find quotients? Think about this question during the lesson. How can you use area models to find quotients? Think about this question during the lesson. Emily has a rectangular garden with an area of 360 square feet. The length of her garden measures 20 feet. How many feet wide is her garden?
So notice we have, it's a little bit different. In the area model that we saw here, oh, not right there, right here, we saw that we had, or we were finding what's on the inside, right? We were finding the total number we had. But that's a little bit different for this one. We're given the total. We're given our dividend, how many we have total, okay? And we're given one of the numbers on the side, which is our divisor. Our unknown number this time is our quotient, which is the one that's on the side, which in multiplication, we're used to be given the two outsides, and we're finding the total. But for division, it's a little different. We're given the total, our dividend, of 360. We're given the divisor, one of the sides, which is 20. And we're finding our other side, which is our quotient. So it's the same view, but we're just approaching it a little bit differently. So let's see how we do that.
Emily's garden has an area of 360 square feet and a length of 20 feet. Why is the garden's width not shown? The width is unknown. You need to divide the total area by the length to find the answer. You can have W stand for the unknown side. Think 20 times W equals 360, or 360 divided by 20 equals W. Find the unknown side length. How many tens and ones are in the quotient?
So just like we did with multiplication over here, when we split it 43 into our tens and our ones, and 24 into our tens and our ones. We're still doing that same strategy to help us figure out how to do this problem easier. So we're setting it up like we did before, just we're finding a new unknown.
Find the number of tens. Try 110. The area of a rectangle with a length of 20 and a width of 10 is 20 times 10 equals 200.
So notice they still did multiplication here. So they did 20, or 20's here, times 10 gives us the 200, which is what we're used to seeing in the multiplication area model. Let's see if we can find out what else our unknown number has. So we started with the tens.
How can you decide that there is 110 in the quotient?
Well, something we did when we did it before was we tested and saw how many tens we could do. We did 20 times 10, which we know from this is the 200. So we then would test if we could do 2 tens, so 20 times 20, which are 0 times 0 is 0, 0 times 2 is 0. Then we're done with the ones place. 2 times 0 is 0, and 2 times 2 is 4. So if we add those together, that gives us 400, which we know is too big when we look at our total, which is 360. So 400 is too big, so that's why we look at just 110.
20 times 10 equals 200, and 20 times 20 equals 400. Since 400 is more than 360, you know the quotient will be less than 20. The area of this section is 200. The remaining area is 360 minus 200.
So notice, just as we do with our long division, when we subtract what we've taken out already, that's what we're doing with this area model. So what they've done is if we look at our long division, right? And we have this here. So we have our 360. And we know that we're dividing by 20. They looked and said we can do 110. We know we can't do our hundreds, but we can do 110. So we did 20 times the 10 equals our 200. So we subtracted that. And that gave us 160. Okay, so that is where that came from. That is how it relates to what we know already.
Find the number of ones in the quotient. How many ones are in the quotient?
Select your answer.
So we find that by doing what times 20 equals 160. So 20 times 4. 2 times 4 is 8. So 2 times 4 equals 8. So if I annex that 0, it's an 80, which doesn't work. Let's try 2 times 8. 2 times 8 I know is 16. So if I do 20 times 8, the 2 times 8 gives me 16, and I annex the extra 0. So it's 8 ones, which means we do 20 times 8 to give us the 160.
There are 8 ones because 8 times 20 equals 160, and 160 minus 160 equals 0.
Okay, so just like we did before with our division, we had the 1 set up and we had 160 left over from our total. So this is what we had. We had our 360 and our 20. We put an X here and a 1 for the 10. We subtracted 200. We were left with 160. Then we looked and found that 20 times 8 gives us 160. So we put an A above the ones place, subtract the 160, which gives us 0 left over. So that tells us that 360 divided by 20, why does it always do that? Divided by 20 gives us the 18, okay? So our answer is 18. So I hope that you learned a little bit more about how we can use the area model for division. We know how to do it for multiplication. Now we have an idea of how to do it for division. Make sure that you go back to our main group and do the quick check, and then we'll be ready to go for small groups today.